Okay. So lesson 34. If a quadrilateral is a parallelogram, then there are some wonderful properties that we need to know. Okay, the first one says, then its opposite sides are congruent. No, that's that's number 3, but I don't know that it really greatly matters. Its opposite sides are congruent. I guess all of a sudden today I'm going out of order. Parallelogram. Opposite sides are congruent to each other. Which most of the time we'll say parallelogram opposite sides are parallel and congruent. But the definition of parallelogram is opposite sides must be parallel. The second one, the opposite angles are congruent. Your opposite angles. What does it mean to be an opposite angle? Angles that are across from each other. The angles that are across from each other are congruent to each other. Next, we have consecutive angles. What does it mean to have consecutive angles?
They're right beside each other.
They're right beside each other. And consecutive angles are supplementary. Consecutive angles are supplementary. What does that mean? So if I have over here angle 1, 2, 3, and 4, consecutive angles, the ones that are beside each other. What's a pair that are beside each other? Angle 1 and angle 2. So angle 1 plus angle 2 equals 180 degrees. Is there another pair that's right beside each other? Angle 3 plus angle 4 equals 180 degrees. Those are this way. What about angle 1 and angle 4? Are they consecutive? No. What? They're not beside each other? They share a side here. They are most definitely consecutive angles.
I guess in mine
they're. Oh.
I did a square and did like 1, 2, 3, and 4.
Oh, so you didn't just go in order? Okay, you start in order and you go around? You didn't do that? Okay.
Just my examples.
Okay.
That's what I was confused.
But mine is. Or we can do angle 2 and angle 3. And the fourth property. The fourth property, the quadrilateral is a parallelogram, then the diagonals bisect each other. What is a diagonal? What is a diagonal? A, B, C, and D.
Goes from one opposite angle to another. Mine does.
Okay. It connects. It's a segment that connects non-adjacent vertices. So they can't be beside each other. So how many diagonals do we have in a parallelogram? 2. So we have A to C, and we have B to D. And if where they intersect, we have a point P. What does it mean to bisect something? What does it mean for something to this bisects something else?
It cuts it down in half, equal the middle.
Split it in half. It's in the middle. It's right, cutting it in half. I don't know another word. There's equal amount on both sides. Means P is the midpoint of AC, correct? So if these two diagonals bisect each other, means DB bisected AC. So does AP have to equal PC? Does DP have to equal PB? Yes. Do you see two congruent sides? Eventually we'll turn into a proof, because when we have vertical angles, then we can prove congruent triangles inside. Okay? Not yet, but that's kind of where this is going. If you have some shape, and you're saying, oh, but these diagonals bisect each other, then guess what? You automatically know it's a parallelogram. Eventually we're going to talk about proving quadrilaterals are parallelograms, and we'll come back to these four things. If the opposite sides are congruent, guess what? It has to be a parallelogram. If opposite angles are congruent, then it'll be a parallelogram. We'll have the converse, basically, of all of these. Okay? So how can we use some of this in problems? Let's draw a shape. And I tell you that this is a parallelogram. I'm going to give you this is 16W and this is 90 minus W degrees. And you're asked to find the measure of each angle. What is the measure of each angle? So question is, if you know one angle, can you find out the other three? Yes. And sometimes you have to know, how are these angles that are given to me, how are they related to each other?
What's the double 90 dash
90 minus W. So the question is, how are these two angles related to each other? Are they opposite angles? They're consecutive angles. They're ones that are right beside each other. So the property that says consecutive angles are, what are the consecutive angles? They're supplementary. So do we set this up as 90 minus W plus 16W equals 180? Is that what you did? Because they're not equal to each other, correct? So do we have to solve for W first? Have you solved for it? Are you stuck?
A little bit, yeah. I am.
Okay, how are you stuck? Why are you stuck? It's an algebraic equation. You like algebra, right?
Oh, wait, okay.
Solve for W. You have one unknown. What do you do? What are you going to do? Who's got the next step? What are you going to do, Sadie? Now, if you divide by 16, you have to divide everything by 16. If you divide one side by 16, you have to divide everything by 16. It's the only way they're equal. Does that help you at all? You don't want to divide until you have W by itself on one side. What are you going to distribute? Okay, what's in between it? Is that a multiplication sign? Okay, so maybe we do need to slow down. These are things I expect you to know. When I take off the parentheses, what happens to 90 minus W? It's simply 90 minus W. And so does anything change when I take those parentheses off? Nothing. So when you get rid of the parentheses, when I can't do anything in my parentheses,
So you would make that 15W.
you're just collecting like terms.
Yeah.
So that's literally just 15W. 90 minus 15W equals 180.
W.
What are you doing next? Oh, that's a plus. Sorry.
You subtract the 90.
Subtract 90. 15W equals 90.
Divide by 15.
Divide by 15. W equals 6. Is that our answer? Is that where we stop?
No.
No, please don't. So when you plug it in, angle 2 and angle 4. I just wrote angle 2 there. Angle 2 and angle 4. What do they equal? Separately, what's 90 minus W?
84.
90 minus 6. I was like, the other one ends in a 6. Angle 1 and angle 3 equal what? 96. Because they have to be the same because they're opposite angles. Okay. What happens if we do another one? We're going to pretend I can draw this. After the third time drawing it, we're going to pretend it's not going to turn out well anyway. Because it's not going to. We're going to pretend that I have right angles. When I took this parallelogram, so this is parallel to this, and this is parallel to this. Okay? And we're just going to pretend like it still looks like a parallelogram. And when I cut a diagonal, I actually cut it into two separate right triangles. Okay? And I know the lengths of some of my sides. Well, I was going to tell you. The length of the diagonal is 1 mile. Okay? 1 mile long. And we have the length of the other two sides over there, and they're X miles and 2X miles. In the other part of this, I know.
Is the actual shape a rectangle?
No. Parallelogram. What? Should they be two congruent, equal triangles on each side? Yes. Because they're parallelograms. And I could prove it by side, side, side. But it's not a rectangle. Because if it was a rectangle, that right angle would go all the way to the bottom.
Oh.
Bless you.
Thank you. Excuse you, John.
3x minus 1 up and a 9. Was a minus 1. And the question says solve for x and y. To the nearest. What are you gonna do? Can you solve them simultaneously? Should we solve for x and then solve for y, or solve for y and then solve for x? Yes, Jackson.
I think solve for y first.
Sure, solve for y first. What do you want to do with y?
Something equal to each other. Well,
Wait.
two angles.
Are these two angles equal to each other? And what tells you that?
Because they're opposite angles. Wait, no.
Supplementary.
Wait, because it's 90 degrees.
All I'm looking at is a blue triangle.
Three y minus
Then you have
equals
yeah, equal
9y
times
plus
equals.
2.
So you're telling me these two angles equal each other.
Yes, because that one's
This
a right
angle right here and this angle right here, they're equal because that's a right angle.
Yes.
No.
Because in a
No.
right triangle, the
They add up.
acute angles are always.
They are complementary.
They're always less than
They're
that.
complementary, and there's already a 90 up there,
Yeah,
They're complementary.
so they have to be the same.
I said
thing,
that first
right?
pack.
So that has to be 45 and 45. They have to be equal.
No, but they equal for they
They
equal.
equal-
I was thinking of the other thing.
Boom. Yeah, that's right, Paxton.
Yeah, I was thinking of that. Good
Yeah.
job, Lucas. You got that.
I was kind of doing that for myself. But yeah,
But no.
like you said.
Okay, if you don't remember, there's a corollary that tells you the acute angles of a right triangle will always be complementary. If you don't know that, you know the sum of all the angles of a triangle equal what? When I add 180. If I were to add 3y minus 1 plus 9y plus 2 plus 90, we would set that equal to 180, yes? If you insisted on adding
What are you doing on time?
equals 180, if you subtract 90 immediately, that's what you're left with. And this just saves you a step, a headache to do that. Okay, so can we keep going? I put parentheses because parentheses are most of the time needed. But when I pull them out, what happens? Does anything change?
No.
No. So I just need what? Like times, so 3y plus 9y
12y plus 1.
plus 1 equals 90. Subtract 1. So 12y equals 89.
That work. Above the 89.
I don't know.
No, you have to solve for it.
Solve for y. What do you do? Okay. You guys, we need to start reading the problem and context clues. Do you see it?
Oh.
7.41.
Okay. Maybe they're probably not going to come out evenly when it says to the nearest 100. But then it's kind of funny. There's a question that says that, and one of them comes out even. And that drives kids crazy too. That one I see more than this.
7.1.
Put in your calculator.
Well, Johnny was like,
Hey, calculators are okay. 7.42 is what I believe it is. All right, so we've solved for y. How are we going to solve for x? Can we plug it in anywhere? What we just solved for with y, is that going to help us at all?
I was going to do the Pythagorean theorem for x, but
Okay.
I didn't think it worked.
Why?
Because, like, add them together and it would have been 3x squared equals 1. Because I did 2x squared plus x squared equals 1.
Okay, biggest question is, you have what type of triangle?
Right.
A right triangle. And what is this 1 mile and x and 2x? What is it
Oh, wait.
representing?
I'm
What is that representing? Side lengths. If you have a right triangle and you're talking about side links, you better use the Pythagorean theorem every time.
Every time.
Every time. Okay? But I will say with Paxton, the way he set it up was probably not.
And it was
Correct.
completely wrong.
So when you're setting this up with a squared plus b squared equals c squared, what should we write down?
2x squared plus x squared.
Okay, should I
No.
think before I start writing it down? Which
Yes.
one is my hypotenuse?
2x.
It's 2x the hypotenuse.
Oh, yes.
It's across from the right angle. And does that matter? So this side length is x squared plus 1 squared equals 2x squared. Now I put a lot of stuff in parentheses that I really don't need to. But I kind of want to make a point. What does it mean to square something?
Times it by
Times it by itself. So when I say x squared, what do you get?
X times x.
X times x, which is x squared. 1 squared, simply 1. 2x squared. Really?
Or
Did you
x.
multiply it by itself?
Do you want backlash on that answer?
I know, that's the question, what I've gotten all day. I keep thinking you're going to tell me the correct thing. No. But I need you to multiply it by itself. So I put that in parentheses every time. That reminds me to say it's 2x times 2x, which is 4x squared. Now, can you solve for x?
Yes.
Yes,
You
go.
can subtract. Okay.
Okay, go ahead. What are you going to subtract?
Subtract x squared.
Subtract x squared
On both
from
sides.
both sides.
I have a question when you do that.
Yes.
So when you subtract the x squared, would that be
No.
3x squared or would that just be 4?
Okay, that's a big question. You have 4 apples.
Okay.
4, and then x squared is an apple. And what did we take away? An apple. You have 3?
Yes.
You have 3 what?
Apples.
Apples.
But
Okay.
x just like
Thank God.
disappeared.
No, it didn't.
Oh, it's 3x.
4 apples minus 1 apple.
So x is 1/3.
What?
No, stop.
It's just 3
Stop.
x.
Write down 4x squared minus 1x squared. 3x squared. Okay? How do you solve for x? What are we doing next?
Oh, the square root.
We divide by 3, correct? So x squared equals 1/3.
Now you have to do the square root of
How?
each side.
Square root of both sides. So x equals the square root of 1/3.
Is that possible to find?
Yes, you plug in your calculator because it said to the nearest hundredth.
Could you do that without a calculator?
No. Oh, yes. If you want, do you want to know the exact answer? It's the square root of 3/3.
Wait, what?
Yeah, wait, what? You don't want to know the exact answer. Because this is really the square root of 1 divided by the square root of 3. That's how you translate that.
That makes sense.
But you can't leave square roots in the what square root of 1 is 1. But you can't leave square roots in the denominator, but you don't know that yet. So we multiply. That's square root of 3 of 3.
But like, could you solve it without using a calculator?
Yes, I did, and that's an exact answer.
But how do you get that?
So the square root of 1/3. Issue is you need to stay in geometry. Okay, for now. You're in geometry, your brain needs to stay in geometry. When it says round to the nearest hundredth, you plug it in your handy calculator and you give me that answer. But I guarantee if you plugged in the square root of 3 divided by 3, you're going to get the exact same thing. And in most of my classes, you're going to say, I'm going to say, what's the exact answer? I don't like calculator approximations. What's the exact answer?
0.57350292.
Oh, dang.
That's not the exact answer.
No, because I just put in a bunch of 3s, so it kind of like.
No.
Square root of
I did that too.
No.
To get like as close as possible.
Oh, what?
It's 3 repeating.
Yeah. Okay. Then why didn't you put in 1,000 more 3s? Because there's 1,000 more 3s there.
I don't actually
Actually,
do that.
there's 2,000.
1 divided by 3. Enter. You get close, but eventually you mess up.
Dang,
But
you
1/3.
You would never know.
You're right, 'cause I just wanted decimals.
Yeah.
I just want 2 decimals. What's your 2 decimals?
Let me see how much.
Now, let me show you something else then. If you did the square root of 3, divided by 3. It's the exact same 2 decimals.
What? Wait, how?
What?
But it's 1. No, you
That's like
What?
this. You just found the square root of 1, Lucas.
Dude.
3 divided by 3 is 1.
No.
That makes no sense.
It's what I did. It's an exact
No,
answer.
that makes no sense.
Why?
Because if you
It does.
It just
Okay, we'll
doesn't
have
make
this
sense.
conversation later.
This is world changing. Someone
Okay.
say earth shattering.
Everybody else's answer is x equals 0.5, correct?
Oh.
It's only more.
You don't know what?
I can't brain.
I have no idea what just happened. Alright, let's get a piece of paper out.
World changing.
Let's look at letter A. Forget what letters it told us they were. A, B, C, D. Find the value of y.
That's what World War III is going to be based on.
A, B, C, D. Can you find the value of y? 4y minus 10. And then you're given 2y plus 5.
Wait, what?
Oh,
Are we?
Too busy laughing.
you do 4y minus 10 plus 2y, what is that? Plus 5
Equals.
equals 180.
So how are these angles related to each other?
They're congruent.
Then you have to answer that question.
Oh,
How are they related?
they're congruent.
No, I don't want that answer.
The
How are they
ultimate
related?
interior angle.
No. They are opposite angles. And you go up to your properties. Opposite angles are congruent.
Oh my god, I'm gonna guess.
So 4y minus 10 equals
Negative.
2y plus 5. Alright, listen. If you've got stuff to do, we're going to practice A through E, but not D.
Oh, thank goodness.
Okay.
If we had done G,
Alright, let me just make my hand.
Man.
When you get to it, you won't do it. If you want to get extra credit, you can do letter D.
wall.
Okay.
Okay?
Just have like a mediocre.
Extra credit, more like cheaper GPA.